What is illusion and how do we see illusions? Today I'm going to tell you the secret of illusion through 3 interesting illusion examples. Let's begin with this picture. Here is a grid. Nothing special, right? But look closer into these white spots at the center where the 2 central vertical and horizontal lines intersect. Do you see anything funny or special? Keep looking and stare at the spot for 5 seconds. Now, look at the other spots. Are they still white, or do they show flashing of gray? If you can see the weird and funny flashing spot, you might want to ask me how it can happen. The gray spot doesn't exist in the reality and also paper. But why can we still see it? It is the error result processing by our brain visual system. You might be amazed that our most delicate organ, brain, will make a mistake. It sounds impossible, but it's true. Our brain isn't perfect. Information cannot be analyzed 100% accurately under certain circumstances. While there are really only black blocks and white spaces in the grid, the high contrast black and white areas fool the eyes into perceiving a gray circle at each intersection. The illusion results from retinal cells adjusting the brightness of an image by adjusting the intensity of the light signal in many small sections, which allows you to see a wide range of both bright and dark details in the same image, unlike a computer monitor or TV screen that has one brightness setting for the entire image. The size of these small sections is determined by the size of neural receptive fields in the retina. The fovea, an area near the center of your retina with the highest resolution vision, has the smallest receptive fields and the highest number of photoreceptor cells. Areas of your retina dedicated to peripheral vision have larger receptive fields, and therefore lower resolution viewing. In the Hermann grid, the intersection that you are looking directly at falls onto the fovea, which has very little lateral inhibition due to the small receptive fields and high concentration of photoreceptors. Our perception within this area is fairly accurate, and we see the areas as either white or light gray in the area within the green circle. The dark and light areas are balanced, so no gain adjustment is needed, and we see this area as white. At the purple circle, most of the receptive field is flooded with white light, causing strong lateral inhibition which results in reduced gain in an area that appears gray. Now you know the secret of these illusions, that our brain isn't perfect. Interesting, isn't it? This is also shown by the following examples. Here is another picture. What did you see? There are a lot of black and white circles. Yes, you are right. Let's focus on the pink area. Do you think they pop up or digging down? As we all know, they look like digging down. Now I'm going to mirror this picture. Look at the yellow area. They pop up instead of digging down. Are magical things happening in the image themselves? Alright, let me tell you how this illusion tricks our brain. Your brain's visual cortex operates on assumption about the lighting of the image. It expects light to come from a single source, shining down from above. And so these shading patterns could only have been caused by light shining down on the sloping sides of a dome, or the bottom of a hole. If we carefully recreate these clues by drawing shading patterns, even on a flat piece of paper, our brain reflexively creates the 3D concave or convex shape. Do you feel like you're getting to understand illusions? If you don't, that's fine. So let's move on to the next picture and see how it tricks us. As usual in these things, these two lines are in fact parallel, but you perceive them to ball outward at their centers. At the center where those radial lines are, it's wider in your visual fields than the parts above and below. And this is remarkable because it's a remarkably simple stimulus. It's just a bunch of straight lines. Why should one of the most complicated objects in the universe be unable to render this incredibly simple image? When you want to answer questions like this, you need to ask, well, what might these mean to your brain? And what your brain is going to think this is. It's not some lines on a page. Your brain has evolved to handle the kinds of natural stimuli that it encounters in real life. So when the brain encounters stimuli like this, well, it seems a bit odd, but in fact, you've been encountering this stimulus all day long. Whenever you move forward, in particular, when you move forward, you get optic flow flowing outwards in your visual field. You have to understand that our brains are slow. What you would like is that when light hits your eye, then bang, immediately you have a perception of what the world is like. But it doesn't work that way. It takes about a tenth of a second for your perception to be created. Since our brain cannot have the same perception with the world, it creates a best guess about the next moment. What will the world look like in a tenth of a second? Build a perception of that, because by the time your perception of the near future occurs in your brain, the near future will have arrived and you'll have a perception of the present, which is what we want. This is how our brain compensates for its slowness. Let me end by showing this picture and once again feel the illusion together. If you just stare at black points, which is in middle, and trying to shake your head back and forth because of the blurs of the optic flow lines, your brain says they are probably already moving, and that's why they're blurry. When you do it, they should be bursting out in your visual fields faster than they should. They shouldn't be moving that much. So, what is the secret of illusion? What I've been saying is that our brain isn't perfect. However, this is enough for us to living a good life. These imperfects also bring us entertainment. This is why the illusionist show is so popular in the world. People love to see the impossible happen right before their very eyes. Seeing someone appear, disappear, levitate, or get sawn in half. These magic tricks are all rely on the imperfect of our brain, which is called illusion. Pay attention to the surroundings and you will find that illusion is everywhere. Maybe next time when you see the illusion or when you are watching magic show, you can have a better guess. Thank you.